Kester Badenas, and I'm from Puerto Princesa City National Science High School, and I will be a teacher for today's lesson. So before we discuss the topic for today, let us first have a review on what we have discussed last meeting. And I think that those topics would be essential for today's topic. So in order for you to recall the lessons that we have discussed last meeting, let us have these guide questions. So first question, what is a prime number? Number 2, what is a composite number? And number 3, can we represent a composite number using prime numbers? And if yes, how? All of your answers and guess are correct. So, what is really a prime number and a composite number, and how do they differ with each other? So, a prime number is those integers who has a factor which is only 1 and itself. Let's take for example, we have 2. 2 has only 2 factors, 2 itself and 1. So, if a number has a factor aside from itself and 1, that is what we call a composite number. Let's take for example, we have number 4. Number 4 has 3 factors. It can be 1, 4 itself, and 2. Since 2 is the additional factor, it is not a prime number anymore. And that means it is now a composite number. So we have 25 prime numbers from numbers 1 to 100, and we have 75 numbers from 1 to 100, which is composite. And I think that those numbers would be useful for our today's activity. So let me remind you of the prime and composite numbers from 1 to 100. So we have here a number. So we have number 12. And we all know that 12 is a composite number. And since 12 is a composite number, therefore, we could rewrite it as a factors of prime. Okay, so 12 obviously has factors. Let's see that those factors is 3 times 4. And since 4 is a composite number, therefore, we could rewrite also it as factors of 2 primes. So we have 3, 2, and 2. And these prime numbers are actually the factors in getting a product of 12. So we can say that when we rewrite 12, a composite number, as a factors of prime, we have 3 times 2 times 2. And since 2 occurs twice, we can express it as its exponents or as the power of recurring prime. So we can say that 12 is 3 times 2 squared because 2 is repeated twice. And that process is what we call prime factorization. So before we proceed for our topic for today, let us first have an activity. So I will be giving you a pair of numbers. So I prepared 4 pair of numbers, and I will be giving you each pair that is actually differentiated accordingly to your mathematical ability. So all you have to do is you need to follow my instruction using those pair of numbers. So before anything else, are you ready? So if you say so, let's begin. Okay. So step 1, identify the given number if it's a prime or composite. Let's take for example, I have my own pair of numbers. Let's take for example, we have 24 and 72. Okay, so first step, of course obviously, 24 and 72 is composite. So better if you know if your pair of number, each of them would be a prime or a composite. So determine it first. Step 2. If any of the number is prime, underline it. So based on my own pair of number, 24 and 72 are composite. It is actually based on our step number 1. Therefore, we could not underline those because those are not prime. Step 3. If any of each number is composite, write it as factors of prime numbers. So since we have composite numbers here, 24 and 72, and based on what we have learned last meeting, we write these factors, that is, or these numbers, as the factors of prime. So let's take for example 24. 24 is 4 times 6. And we all know that 4 and 6 are also composite. So we better represent those as prime factors. So we have 2 times 2 and 2 times 3. Therefore, 24 can be expressed as 24 equals 2. And it is repeated thrice. So we put our exponent 3 times 3. So 24 is 2 cubed times 3. What about 72? So we have here 72. 72 is a product of 8 and 9. And then we simply just factor out or find the prime factors of 8 and 9. So 8, of course, is 4 times 2 and 9 is 3 times 3. Since 4 is also a composite number, right, its prime factors, which are 2 and 2. Therefore, we can write 72 as 2 cubed times 3 squared. Encircle each factor of a number if it has a pair on factors on the other number. So let's check the factors of 24 and 72 in my case. So as you can see, if those factors has actually the same number or same, let's say, same number, encircle those numbers. So let's check my number. I have 24 and 72. Since 2 cubed and 2 cubed occurs on both numbers, encircle those and pair them. Okay? Can we encircle 3 and 3 squared? No. Why? Because they don't have the same power. And if we rewrite 3 squared as one number, we all know that we will have 9. So 3 and 9 are different numbers. So before we proceed to step number 5, I have a question. So what do you think are these numbers that you have encircled? You just encircled a same number, right? So what do you call or what can you say about these numbers?
Same.
Very good. They are same. And they are common in both numbers. So we call that common factors. Step 5. Write each pair of numbers as one number. So we rewrite 2 cubed. Since we have two cubes here and we pair them, that pair should be rewrite as one number. So we only write 2 cubed here. Okay, so 2 cubed. So if we have different pairs, aside from my number, because I only got 1, so if you got 2 or more, you write all those pairs. And then, step 6, multiply all the numbers you have and box the product. If you have only got one number, box it. So I have here 2 cubed. Maybe you have 2 squared or 2 raised to 4 there. Okay, so instead of boxing it immediately, better to rewrite this as one number first. So we have 8. Very good. So box 8. Since I only got one number, but if you got 2 or more, multiply those numbers and box it. So question, what number did you get? Mine is 8. How about yours? Step 7. try to divide the number you get from the pair of numbers you have. So let us divide 8 with 9 numbers. So I have 24 and 72. So let me divide to you my number. So I got 8. So 24 divided by 8 is 3. 72 divided by 8 is 9. Now, question. Did each number yields an answer without a remainder? In my case, yes. How about yours? What do you think is 8? What do you think is this number? Analyzing our activity for today, I have here guide questions in order for you to, let's say, analyze or process the activity that we have earlier. So, I have 3 questions here. So, how would you describe our activity for today? Did you enjoy doing it? Please elaborate your insights. Number 2. What do you think are the challenges you have faced during the activity? And how would you overcome or resolve it? Number 3, what ideas and concepts did you obtain while doing the activity? And number 4, what ideas and concepts that you have learned in the activity will be used for today's lesson? So I know that you have answered it with your own opinions. And whatever answers that you have given to me are actually important in dealing the lesson. And that leads us to our topic for today, which is all about greatest common divisor. Based on our activity earlier, the greatest common factor is the largest positive integer that divides each of the integers. So basically, it's the positive integer that is the largest, that is common to both numbers. So greatest common divisor is also called greatest common factor or the highest common factor. Actually, greatest common factor is actually used in adding or subtracting fractions. And of course, problem solving that will be discussed later on in the discussion. So we have 2 main ways that is actually included in our discussion for today to find the greatest common factor or divisor of 2 or more integers. It could be with the use of prime factorization, through listing method, and by continuous division. We already done the listing method with prime factorization earlier in our first activity. So for the next activity, we will be learning another way of listing. So again, we will be having another activity. So it's actually quite similar on what we have done earlier, that I will be giving you a pair of numbers and I will be giving some instructions for you to follow. Okay, so today I will be giving you a pair of numbers. Some are composite maybe and some are prime. And I have of course my own pair of numbers for you to be guided in following the instructions. I actually flashed the pairs of numbers that you are about to do with our activity for today. And of course, again, I have here my pair of numbers. So, are you ready? Okay, so step number 1. So, factor each number with any 2 numbers as shown below. So, I have 30 and 75. So what we are about to do for today is to do the factor tree. I think that most of you are actually familiar with this factor tree. But for the sake of everyone, we will be doing that in our video. So a factor tree, basically it's a pyramid or a tree, or yeah, it is called tree because we have branches of the factors. So based on our first step, we need to factor these 2 numbers using 2 factors. Okay, so 30, let's say 30 is 10 I guess so. And 75 is 15 times 5. So that's for step 1. Step 2. If the factor is prime, underline it. If it is composite, factor it further. So based on my pair of numbers, if the factor is prime, based on our step number 2, underline it. Unless, if it's a composite, now, factor it further. So for our 10 here, let's have, of course, 2 and 5. And for 15, 3 times 5. Step 3. So repeat step 2 until all primes after the 3 are all prime numbers. So let's check if all our numbers are prime numbers. So if we saw any composite numbers under the 3, we should factor it further until all the numbers under the 3 is a prime number. So 2 is a prime, 5 is a prime, and 3 is a prime. So those numbers under our 3 are all prime numbers. So therefore we need to stop the step 3. And we don't need to do the step 3, so we skip it. So let's have step number 4. But unless you need to factor it further, we will wait for you. And do step repeatedly until you finish the step number 3. Okay? Step 4. Look to the prime numbers at each endpoint. If the numbers have the same factor, pair them and encircle them. So let's check our prime factorization here. So let's pair them. So let's have 5. Since we have 1 5 here, we circle another 5 here. So I guess that's the only number that is actually the same. So I only got 5. How about yours? Oh, I see we have also 3 here. So 3. So we need to pair them. Do we need to encircle this another 5? No. Why? Because we have only 1 5 for our factors for 30. Unlike in 75, we only have 2. Since this 5 has no pair, we don't need to include that. We only need to have those numbers to have pairs. Okay? So for step 5, write all the pairs as one number and multiply them. So we have 5 and 3. So multiply them, that is 15. As shown here, we have 15 as our greatest common divisor. So what number did you get for your product? So that would be the greatest common divisor of the pair that we had. And then, so in step number 6, you need to divide the number that you get from the pair of numbers you had. So in my case, we need to divide 30 and 75 with 15. So 30 divided by 15 is 2. And 75 divided by 15 is 5. So again, question. Did each number yields a remainder? If no, that would be the greatest common divisor. And of course, since it's a divisor, a common divisor and a factor, we of course don't yield a remainder. Okay? Remember that. So if you have any remainder with your factor, therefore that is not the greatest common divisor anymore. And what we have done here is the listing method using the prime factorization. So our next activity would do something about the continuous division. Again, I will be giving you a pair of numbers. Or let's say, let's have your numbers earlier that you have used. So again, let's have 30 and 75 as my number. Let's see if your number that you've obtained earlier in the prime factorization through listing method is the same as the continuous division as we do our activity for today. So we have first step. So step 1. Think of a number that can divide both numbers. You can have the reference in solving in my board. So since I have here 30 and 75, so you write it like this, 30 and 75. And then, what do you think can be divided by these numbers? So we have 5. So 30 divided by 5 is 6. 75 divided by 5 is what? 15. Very good. So we have 6 and 15. Next step. Step number 2. Continue dividing with a number that may divide those numbers until the numbers below are relatively prime. When we speak of relatively prime, it is the numbers that do not have the common divisor. So let's take for example, 3 and 4 has no common divisor that can be divided in both numbers, so they are relatively prime. In this case, 6 and 15 has numbers can be divided into, so that would be 3. So we have 3. 6 divided by 3 is 2. 15 divided by 3 is 5. Is 2 and 5 both relatively prime with each other? If your answer is yes, then we will be stopped here. In the next step, multiply the numbers that you have divided. So what are the numbers that you have divided? It is actually obvious here in this part or in this column. So you have 5 and 3. So multiply them. So the answer is 15. And I guess we have 15 as greatest common factor using the prime factorization through this method, right? Very good. So 15, whatever method that you use using the prime factorization or the continuous division, both of the answer yields the correct greatest common divisor. So if you have any questions, just type your comments in this video. Today we will be having async work. Just to check if you really understand what I'm saying here. Okay, so I'm just kidding. So I will be checking if your answer is correct. So today we will be having a short activity we call fixing skills. This is actually equivalent to our SEEK work to check that the knowledge is enough for you to answer the lessons that we have discussed earlier. So we have 2 pairs here. So all you have to do is to find the greatest common divisor using any of each method. The activity is actually shown on screen, so let's check. So that would be the first thing that we should do. So we have numbers 108 and 120 for the first pair, and 270 and 81 for the second pair. Okay, so we will be doing 108 and 120 using the prime factorization. This is for first pair, right? Okay. So 108 and 120. So let's use the factor 3 to be able to find those prime factors. So we have 9 and 12. Am I right? And then we have 3 and 3, 3 and 4, and then 2 and 2. So for 120, let's have 10 and 12, and then 5 and 2, 3 and 4, 2 and 2. So these are the prime factors. Okay, so don't forget to underline the prime numbers. Next, we pair them. So 2 and 2 has prime, 2 and 2, 2 and 2, and then 3, and then 3. Okay, so 3, 2, 2, 3, 2. Okay, very good. So we have common factors here. And then we multiply those numbers. 3 times 2 times 2. So what's the answer? 12. So 12 is the greatest common divisor of 108 and 120. Did you get the same answer? If you do so, very good. If you don't, let's try another number. Okay? Don't worry, you will learn a lot. Okay, so let's have the second item, or the second pair. So we have 270 and 81. Okay, so we will be using the continuous division in this pair. Okay, so we have 270 and 81. So what do you think the number can be divided in this number? Okay, let's see if 9 will do. 9. 270 divided by 9 is actually same as 27 divided by 9 is 3. But we have 0, so it's 30. And then we have 81 divided by 9, 9. And then 30 and 9, we have the same divisor that can be divided with both numbers. Yes, let's have 3. 3 is divided from 30, that's 10. And 9 divided by 3 is 3. Do 10 and 3 relatively divide with each other? Yes, they do. So we stop here. Okay? So multiply the numbers in the first column or in the left. So we have 9 times 3 is 27. So that is the greatest common divisor of 270 and 81. Okay, to have you another challenge, use the methods in step number 1 and step number 2 that we haven't do in this video. And let's check if your answer is same as mine. Okay, so that will be your challenge. So now, as I said earlier, that we will be having a problem solving, right? So I have here a problem, and this is be done by doing the greatest common divisor. So what is the problem? So let's flash it on the board. So Mark and Mark are twins, and they want to share their sweets. Mark has 24 gummy bears, and Mark has 18 candy bars. If they want to share their sweets in such a way that each of their friends will have the same amount of each type of sweets, how many friends could they give sweets to? Based on our problem earlier, Mark has 24 gummy bears and Mark has 18 candy bars. Okay, so all we have to do is to group in such a way that each loot bag, or let's say each group of sweets, has the same amount of candy bars and gummy bears. And later on, we will check if how many friends are, or how many friends we will be receiving that sweets. Okay? So if Mark has 24 gummy bears and 18 candy bars for Mark, we can use the greatest common divisor to group them equally. Okay? That each bag contains the same amount of gummy bears and candy bars. Okay, here. So any methods will do, but in today's activity, we will be using the prime factorization or the factor. So 24 and 18. 24 is 6 times 4, 18 is 6 times 3, 4 is 2 times 2, 6 is 2 times 3, 6 is 2 times 3. So let's see. So we have 2, 3, 2, 3, and we pair them. Okay, so we write the number or the pair of numbers as 1. So 2 times 3, that gives us 6. Okay, so 6 is what? What now? We obtain 6 as the greatest common divisor. Mark and Mark will be giving to their 6 friends who receive the same amount of gummy bears and candy bars. Oh, how generous. And those 6 friends will receive the same amount of gummy bars and candy bars. Okay? So that is the one way of solving the greatest common divisor using problem solving rules. So of course, this lesson is not about cognitive only, but also in your affective and how would you apply it to real life. So I'll hear some guide questions for you to help to analyze that why we are studying math, why we are studying greatest common divisor. We're just only doing it for numbers. So let me ask you, how could we apply or represent the concepts you have learned for today's lesson in our daily life? Very good. I think that would be same also as what I am thinking of. And what values can you get from learning the topic? So you may share any values that is important in solving greatest common divisor. What aspects did you change? Or maybe what value did you obtain that in order for you to find the greatest common factor, you need those. Especially if you're not really good in math. Very good, and thank you for sharing. So if you have some, you may comment your insights on the comment page or the comment section. And of course, let's end this lesson with a generalization. And we can conclude those things that you have learned. Okay, so what have you learned for today's topic? So today you have recalled how to write composite numbers using prime factors or the prime factorization, and what is the greatest common divisor, how to find it, and how would you solve it using, or how would you solve problems using it. And of course, you relate it with your daily life. And I guess with those learning that you obtain from this video, you will learn a lot. And of course, you will learn a lot from another video that I am about to share in the future. Maybe. I don't know. Okay. To challenge you further, we will be having a seat work, a virtual seat work. So I will be posting the answers on this post that is actually included in this video. And let's see if your answers are correct based on the given. So I give 3 items in your seat work and 1 problem solver. I hope you learned a lot from today's video about the greatest common divisor. So thanks to my professor that encourages me to do this video because it's actually one of her requirements. But I guess this video will be helpful, especially for those who are in the elementary level. And hi to my classmates and UPO. Just regards. Okay, so again, I am Kester Badenas, all the way from the beautiful Puerto Princesa City. And thank you for watching my video. I hope you learned a lot. Stay safe, God bless, and thank you very much.